First piece I'm going after this week is the tray for this little machine. Going to run a file across the bottom, just see how flat it really is. That's not too bad. Coarse file, be careful the file doesn't clog up. It'll put dig marks in very soft material, and then you have to remove 3 times as much material to get the dig marks out. So take care of that. Some say chalking the file is a good idea. I cleaned up the edges of the tray on the belt sander. Now I'm going to clean up the back face with emery, laying flat on the bandsaw table. It's a great place to do this. Preliminary filing, sanding is done. Bottom's clean enough for the application, and occasionally too shiny is not a good thing. There is a small divot in the tray right here. Just, it's not a game changer, not at all. This is perfectly fine just the way it is. Blasted, you probably wouldn't even notice. But I'm going to set it up in the mill, and I'm going to deck the inside of this off, and I'm going to make that go away. Because it's just got to be that way. All right, off to the mill. And this is one of those times where you need to make sure that when you turn your dial, you turn it in the right direction. When you're up against that wall, you turn it the wrong way. That part is toast. Let's do it. Using an end mill that has a diameter that will match the internal corners of this tray, first thing I'm going to do is set the perimeter. And I'm going to bump it in until it just takes a little bit off the edge, and you can see the chips start to flow there. Zero the digital, write the number on the vise face so I have something to read. Those values are what my digital is reflecting when that cutter is in position for that face. Makes it a lot easier. It's just like connect the dots. And by adjusting the depth of the cut, I can make any inclusions that are present go away. That was a very superficial 10 thousandths deep cut, and it appears to have done the job. I'm going to root it up, take another pass. Move it in slowly and deck the entire inside of that out and reblast it. My areas of concern on this little tray are the bottom. The sides are really clean, so the bottom is what I'm looking at. And that red line across the back right there, if there's any red left over after that pass, I know that it's still low, which it is. So very slightly I'm going to start coming up with the table until that red goes away. I know I have a clean surface, and then back and forth across the field. Okay guys, 4 flute cutters, gummy material, and a lack of lubrication. Never a good combo. Little bit larger diameter cutter allows me to go a little bit faster, and the red that you see in the back was strictly to set the height of the new cutter. I ran some emery over the bottom of this, put it back in the blaster, and any inclusions are now gone. Very pleased with the way that looks. Next piece in the assembly is a very small rod with 2 journals turned on each end. Now, since it's easier to size an OD than it is to size an ID, this particular assembly gets little knobs pressed on either end of this rod. So what I'm going to do is I'm going to make those knobs first, check the size of the hole, and then I will size this rod accordingly. And I think that here in a second you're going to see why I'm going to do the rod second. All right, so let's just change this material out. Let's put a little bit bigger material in the machine, make a couple collars, and turn some journals on the end of this part. Yep, now you know why. Starting off with 1/8 diameter brass, Facing operation to clean it up, drill it, pushing through about this is an 047 drill. It's about 1.2, 1.3 millimeters. Forgive me if I'm off on that one. Trying to go deep enough to get 2 parts out of this. And I'll extend the material here in a second to turn the OD. Got to get down to 100, which is, what's that, 2.5 millimeters, just under 1/8 of an inch. Check it a couple times, get it nice and clean, come back in with some polishing compound and shine it up so that it's ready for parting and final application. I know the relationship between the facing tool and the parting tool, so just add my number to the DRO value, file it, and part it off.
Well, looks like I might have missed that by just a hair for 2 pieces. I eyeballed it. I shouldn't have done that. I guess I'm about 15,000 shy. That is a very tiny piece. You can see it clinging to the tip of my retriever here. Another gift from a subscriber. Really like this thing. It's coming out really handy. There you go. Lather, rinse, and repeat. One more piece. We're done.
And now we'll face off and turn the journals on the end of the smaller rod that I showed you initially. Be extremely careful if you have material this small extended, as its tendency to walk up and over the tool is really increased. So stay as close to the collet as you can. And you probably won't have that problem. I'm going to put a cleanup cut on it right here and take it back out, check the overall length, and put it back in the machine for final sizing. And you'll see it hangs out a little bit more than it should, which is why I'm going to be very delicate when I do these little nibbles on the end to bring it into the overall length. Any big cut in that material would for sure walk up over the top of that tool and destroy the part. Be very careful. And for anybody curious as to exactly what I use to polish up this brass, this is called Blue Magic. I really like it, and I got it at an auto parts store local to my house. Next piece in line is a splined material, so I'm holding it very gently as not to distort the teeth. Facing off the one end, drill and tap it for a very small 080 screw that's going to go in there. And that's about a 1.5 millimeter diameter screw. An 080 I think is 062 inch crossed. And the tap is very delicate, so if you're using a tap like that in brass, just be careful and make sure that there's lubricant on it. We know what happens when gummy material hits small cutters. Spring-loaded tap guide. Knurled thumb wheel on the tap gives you great feedback on the small threads. This isn't accelerated footage, so I'm not driving it in that fast, that's for sure. But you can actually feel that tap flex when you use a little wheel like this. If you don't have one, make one. I made mine, and I've used them a million times. Next piece in line is a simple decorative washer. Straightforward. Face it off, drill it, through hole, chamfer, clean it up, done. Hey guys, a quick little shop gem for you here. One of those days you get up and your brain just isn't firing on all 8 cylinders. I know it happens. Make sure, if you're using a digital caliper, of course, set it to 0. Dial it out to the length of the part that you want. Let's say I want my part 1 inch 625-ish. Come on, there you go. Nope. We'll get there, hang on. Speaking of days when your brain's not firing on all cylinders, right? All right, I want my part 1 inch 626 now, so I'm going to 0 this out. Close it and make sure you have the reading that you're looking for. 1 inch 626. Okay, 1 inch 626 is now the standard. When you lay your part in your caliper and close it, it tells you how much material has to come off that part to achieve that overall length. Let the tool do the work for you. It's kind of what tools are for, right? Caliper's no different. Shop gem. Put that one in your box. Next piece is rather small and could be fussy, but I'm going to do it without ever touching an edge finder or an indicator or anything. Let's see, the part is going to look a lot like this. It is 1/2 inch, 3/8. And for you metric guys, that is just about 10 millimeters. And this is about 25.4. This is 1.5 millimeters thick, 0.60 thick. It is relatively small. There is a hole in each corner. And just by knowing the size of the end mill that I'm going to start this piece with, I can do the entire part without ever having touched anything to find out where I'm at. It's a nice technique. Requires a couple of sacrificial aluminum parts. I think you may have seen me do this before. Well, let's put the camera over on the mill, do this entire part without ever touching anything. Well, I mean, you got to touch the part, of course, but here we go. Let's do it. Okay, I'm back. The real part. It's about that big. Tiny little piece. You could mess around with this. You can do the whole thing in one shot. I'm going to do the whole thing in one shot. It might be a couple of minutes worth of setup time, but it's going to save the aggravation. I am doing this part with a 156 end mill. Half of that is 0.78. It's about 2 millimeters. So it's about a 4 millimeter diameter, 2 millimeter radius. I'm going to try to keep this real time so you get an idea for how fast it is or isn't. Cutter's in the machine. I'm going to bring the end mill down below the surface of the jaw and probably the thickness of the part as well. This is very important. I guess I'm about 200 into the vice jaws, about 5 millimeters. Stop this set. There's my sacrificial aluminum plates, finished on one side, saw cut on the other. Popping them in the center. Spacer in between the parts. Make sure the part is registered, which it is. First thing I'm going to do is cut a rail across the back here, 0 out my digital. Now I have a nice little shelf for the part to sit on. I'm going to move the cutter. Let's get it in camera here so you can see it. I'm going to move the cutter back, the radius of the cutter, the 078, and I'm going to zero my digital. Zero it before you move, of course. All right, effectively, I now know that this surface right here is machine zero, part zero, whatever. I don't need an edge finder now to find the back of the part. I just established a banking surface. I'm going to come forward and I'm going to cut a ledge on the front of this too. Doesn't matter how far it is between the front and rear or the rear and the front. Just cut another ledge, basically the same size as this one on this part here. Reason being, when you take this spacer out, this is going to move in. So dimensionally, it's not critical at all where this is. Nothing else needs to be done to the digital at this time. Clean everything off, take the spacer out and put a spring between these two plates. If I was just doing this without narrating it, I'd be done by now. Little coil spring. This is strictly a tool bit. Parts now move just like a regular movable vise would. Dropping the rough blank down onto the shelf. Pinch it. Close the vise. Let's get a better look at that for you. I think you can see now why the shelf height is important. If the shelf height were above the back jaw, when you closed it, these things would cantilever out and close up at the bottom and wouldn't hold. Let's make a little bit of room on that and start this piece. Now I'm going to drop the cutter down into the part, and I'm going to smooth off one side, just one. When you have successfully cut one side of the part. Well, I wish I could get a better angle on that for you, but it is really close in there. Hang on a second. Maybe. There you go. When you've successfully cut one face on the part, shift the table the full diameter of the cutter. I'm going to move the cutter in this direction. 156. Zero out the digital again. Now the outside of the cutter is your 0 point. However much you move the table is how big this part is going to be. Let me slip it out of gear here for a second and drop the cutter down close to the surface of the piece so you can see this. The edge of the cutter is equal to the edge of the part. Now no matter what I do with the table, I can keep track of how big this part is without ever measuring it. I'm going to go for 375 on the shift, just under 10 millimeters. In this position right here, I'll cut the other side of this part, and I will have the width of the part without ever measuring it. And I'll also have a 0 point in the back. And I'll show you how I'm going to do that. I have to go back to the beginning to do that. But we're going to do it. I'm going to nibble away at this one. We know now that this back face that I milled in and reset the digital is a 0 face. Right where the cutter is right now is also a 0 face, but I like my 0 to the back left corner. So I'm going to go back to where I was before. When I shift this cutter 375 to the left, it should end up true to this face right here. Let's move over 375. There you go. That is the initial shift from when I machined this side. I'm going to go back to my 078, which is the radius of the tool. Beyond. And I always do my dials clockwise. Digital or no digital, I always finish clockwise when I can. Okay, now the center of that cutter is over the edge of that part. Zero the digital one more time. When I go to 0, 0 on my digital, the cutter will be exactly over the back left corner, which it is. And now I can do my whole pattern without ever touching anything, without ever measuring anything. That part is cut to size and the 0, 0 is already established. Let's put the drill chuck in there, pop the holes in, and get it done. Part is in the vise, the drill chuck is in the machine. How blind is a bat? Life is good. All right, I'm over the back left corner of this part. I'm going to switch over to the incremental mode on my digital. This is a symmetrical hole pattern, so I'm going to move in and re-zero my indicator or my digital on the back left hole. Each of these holes is 0.62, about 1.5 millimeters off that face. That sounds good to me. Let's do it. Quick look at the part. Symmetry is good. Size is good. Shine it up. All I did was put some polishing compound on a piece of cardboard. Rub this on a piece of very fine emery and I rubbed it back and forth on the cardboard. There you go. Shines it up just fine. Alright. Put this one in the box. Move on. Love it. Okay, I'd like you to bear in mind here that the 4 features that I'm putting in this little piece of steel, 4 different diameters, 4 different widths at 4 different locations. Now the tangent point from each one of these holes will end up on the same diameter. So if I were to turn this down, all 4 of these features would disappear at the same time. There's a little bit of math involved off camera. There's supposed to be 3 of these slots, but I didn't want 3, I wanted 4. And I think you'll notice how the holes change. 2 big ones are opposed to each other, the 2 small ones are at 90 degrees and opposed to those. This will all make sense when this thing comes together at the end. The slots are 16th, 93, 125, and 156. And that's as far as metric's concerned. You're going to have to do the math on that one yourself, guys. But it starts off at about 1.5 millimeters, goes to almost 2, it jumps to 3 at 125, and the 156 is right around 4. So it's pretty close, like 1, 2, 3, 4 millimeters in the width. This is the 156 slot going in right now. The 125 was just cut. And on the back side of the post, I know it looks like it's in line with that center boss, which it is, but it's on the back side of the part. This is the 1 millimeter or 1.5 millimeter slot, the 062. And I am nibbling away at it because I'm not really stocked up on these small cutters, and I hope it doesn't explode, which it didn't. And coming to the front, this is the 093. What's that, about a 2.25 millimeter? Now I'm using a 90-degree 4-flute cutter here, and I'm just using it to deburr these slots. Now bear in mind, because the slots are different widths, the height of this tool is different for each slot. So I back the cutter off for each one, bring it down and bump it until I see the big radius clean up. When I know the radius at the end of each one of these slots is cleaned up, I'll lock the spindle off right there and just feed out. I don't have to do this, but it saves me some bench time and it makes for a much more symmetrical broken edge. Seeing it clean up right there, and draw it out, and away you go. This is strictly visual, not critical at all, purely cosmetic. And to finish the part, we're going to put it back in the collet and we're going to part it off the length. And yes, there are 4 interruptions. Nice sharp tool, good rigid setup. Parting across an interruption is not a problem. There is a risk that the chip that you produce will fall back into the interruption and have to shear off again. It may show up as a vibration in the final finish. If you're using a real thin tool, it might break the tool, but it is possible. It's not something that you should be afraid to do. And a quick look at the results of your labor. I think probably you know exactly what this is and where this is going. Had a lot of video to lace together to do this. We're going to put this machine together in the next video. I hope you'll come back and take a look. This was a lot of fun to make a part like this. I've never seen one this small. Anyways, Joe Pye here at Advanced Innovations in Austin, Texas. Stay well. Thank you for watching. I'm out.